Hello and welcome to Unit 2 of Microservices March 2023. My name is Jen Guile. I'll be your facilitator, Q&A, monitor, etc. for this session this cold West Coast morning. Our topic this week is Microservices Secrets Management 101. And so a couple of housekeeping reminders. If you were with us last week, this will be a refresher. If this is your first time joining Microservices March, then it's all new to you. This year, we're offering a badge. You can achieve the badge by attending all 4 webinars, either live like we're doing right now, or on demand through the On24 platform, and by completing all 4 of the hands-on labs, which if you're attending live, we'll do the lab right here in the workshop if you're available, or again, you can do it afterwards on your own pace. You just want to make sure to use the same email address for all the activities so we can figure out who you are on the back end. Second piece of housekeeping is if you haven't joined NGINX Community Slack, this is a great opportunity to do so. We have a Microservices March channel where you can interact with the speakers as well as ask questions about the labs or the topics, or if you can't just find a link, you can do that as well. So that is available through the resources on your screen, and then we'll have one of our staff members in the back end drop the link to Slack in our attendee chat, so you can jump on it there and join us in Slack. And then a quick overview of what you can expect for this session. So we'll spend about 45 minutes or so on a lecture on Microservices Secrets Management 101, which will include a live demo. We'll transition into Q&A. We may take some questions throughout as well, but we'll give you a nice, good chunk of time for Q&A. So those together will take us to about 9 a.m. Pacific. And then after that, assuming you've budgeted time and focus to be with us all the way to 10 a.m. Pacific, we'll offer office hours that you can use to hang out here with us on On24 and work on the hands-on lab. And we'll be here to answer questions, troubleshoot, etc. with you. Now, of course, this is only available if you're attending live. If you are watching this on demand, we'll just crop that section off and you can hit us up on Slack with any questions. Okay, housekeeping out of the way. I would like to introduce our speaker and expert for today, Robert Haynes, Senior Technical Marketing Manager for NGINX. So Robert, why don't you give yourself a little intro, tell the group what you have been doing with microservices and maybe a bit more about the session.
Yeah, sure, thanks. Well, for a start, I think Jen has overstated it with lecture and expert, but we'll go with what we've got. So my name's Robert Haynes. I work at NGINX as doing technical marketing things, which means building demos and talking like this and writing things. I was thinking about this. Jen said, "Oh, you should talk about your microservices background." I was thinking, well, when did it all start? I guess you can start arguing that some of the kind of foundations of all this stuff went right back to things like, Sun Solaris partitions, if anyone's as old as me, or VMS, if anyone's really as old as me, that had the ability to kind of break big monoliths down into small operating system components. And then obviously we took that same idea of breaking down monolithic operating systems to our applications so that we could break those into small pieces as well. So I guess I've been playing with taking big things and making them into small things for quite a while. I've played with obviously Docker when it first arrived, and Kubernetes and all the services you can do from there. So I've had a fairly wide and diverse background in microservices. I also have made loads and loads and loads of security mistakes over my career, going back at least a couple of decades of people pointing out to me dumb things that I'd done. Mostly seem to have got away with it and found the problems in time, but I'm acutely aware of all of our abilities to make mistakes with how we handle sensitive information, having done it lots of times before. So I present myself to you maybe not as an expert, but as a battle-scarred, continuous learner, shall we say. Anyway, that's enough of the dull background. Let's talk about what we're going to talk about. So as Jen said, we'll take questions. I'll try and take a look at the questions as we go through at natural breaks in this presentation. We will do a lab demo where I'll take you through the lab that you're about to do. and we'll take questions between the two. And then as you're doing the lab, if you stay on to do the lab, we'll be here to answer questions as you go through the lab. And we'll do that through a mixture of the Q&A system within the platform that you're using. When we get into the lab, we'll maybe use the chat a bit more because it's a little bit more interactive. But feel free to add questions. I have a couple of helpers who will help answer these questions. If there's something that's kind of super relevant to everyone, we'll try and get it answered on screen as well. Okay, so what are secrets? What are we talking about secrets? Well, I think this is kind of intuitive for most people, but some obvious examples are things like an SSL certificate and private key pair. There's been a number of instances recently where even CA certificate authorities have lost their kind of like their key, the certificate key, which means anyone can forge a certificate that makes it look like anything you like, and it's signed by a CA. So at an individual level, we use our certificate and key pair to prove who we are. If we lose that then obviously someone can impersonate us. Database usernames and passwords. There's lots and lots of examples of one service having to talk to another and authenticate with that, and use a database username and a password. I'm sure it's all over the place, and there are absolutely people scanning containers on registries and GitHub repos for things that look like database usernames and passwords. And authentication tokens, we use a lot of API calls. A real classic example of that is like a JSON web token, which is what we'll be using today. Just because it's an easy thing to, it's a single piece of data, and it's an easy thing to talk about securing, but another, these are all things. If someone gets hold of an API token, they can use that API. So obviously what we're trying to do in general, at a very high level, is we're trying to take a secret, we're trying to put it into our container app, and then obviously we're going to use that secret to authenticate with a service of some description. And there are various bad people out there on the internet that we're going to try and get hold of these secrets from all of these places. So if I can get the secret either from where I'm storing my secret or where I'm using my secret, I can then obviously potentially misuse that for illicit purposes. So it's critical that we protect our secrets in both in storage and in use. So, what are those key principles? What are the kind of like the big? I tend to have to break things down into like big chunks before I get into little chunks, because that's just kind of how my brain works. So, at a really high level, there are just a few key principles about how we manage secrets. The first one is that we store it securely. We keep that secret. We have to have that secret somewhere. We have to store it somewhere. We have to manage access to that secret, and we have to ideally rotate the secret. We'll talk about secret rotation in the lab and in the session a bit as well. Then we need to inject and store the secret in the container securely, and ideally prevent access to the secret from outside the container. That's kind of a pretty important part of it. And finally, obviously, we need to protect the container runtime environment and the orchestration system, and we need to log when we're using keys. What we're going to focus on today, because these three things in their own could be entirely separate, like to our labs and lectures. So we're just going to look at today how we get that secret into the container, how the different ways we can do that, how we can store the secret in the container, how we can look at a container to see if it's got a secret inside it, or a container image to see if it's got a secret inside it. So that's where we're gonna focus today. But let's just talk a little bit more about how we manage that sort of secure secret storage. So the first thing I should do if I'm storing my secret is I should encrypt it. That's my bad attempt at some artwork to make it look encrypted. But really I don't want it stored in plain text on disk. And then obviously I want to control access to that secret. I don't want to let anyone to have access to that. And obviously I also need to log and audit that secret. So I need to know when that secret's been consumed, who's consumed it, when it was used, when it was last used, and be able to audit and keep a track of where that was. So that means things like secret managers are good. So, you're probably familiar with things like HashiCorp Vault. All of the cloud providers offer a secret storage solution, and pretty much every orchestration platform like Kubernetes offers a secret storage management solution or integration into something like Vault. Today in the lab, we're going to use a very, very, very simple secret storage solution, just because it works well in a contained lab environment. But it's an analog for pretty much any other secret storage solution out there, some of which are more sophisticated and better integrated. But use a secrets manager is what I'm saying. Do not use a spreadsheet or a Word document or a piece of text file to store your unencrypted secrets. That's not an ideal way to do things. I think pretty much everyone would agree. So we obviously need to have controlled, audited access. So we need to make sure that when we use that access, we know that we can put up guardrails around our secret. We need to make that secret hard to access outside the container. Once we've securely shoved the secret into the container, we don't want to make it very easy for somebody else, not without access to that, the runtime of that container, within the container, to get access to the secret. And the other thing we want to do is make it easy to rotate and revoke. So, the other thing is that we have to accept this is the real world. We don't work in a perfectly secure environment. It's probably best to assume that at some point your secrets will leak. Start from that, was that assumed compromise? So assume that at some point your secrets are going to be released, and therefore you need to be able to limit the damage that happens when that does happen. Now, hopefully that doesn't happen to you, and you don't realize that your API token is out there on the internet. But if that does happen, and you have good rotation and revocation procedures in place, and a system that allows you to do that, then you can very quickly shut that down and limit the damage. As I said, secret rotation and revocation. You can set in things like JWTs. You can set things like valid after, valid until, and signatures on those signatures on those tokens as well. And if you're using an identity provider, we're not using anything fancy today with an IDP. We're not going to try and use OAuth or OpenID Connect, just because setting that up for a lab is kind of hard work and makes it complicated and hard to explain the base principles. But in general, if you can use an identity provider, then that's a great thing to do. Okay, so let's talk about the ways to use and the ways not to use secrets in containers. We will be focusing on some of the things not to do, purely because we see them out there all the time. So let's talk about how not to use it. So don't hard code the secret in the container image. Even if you're never intending to put it on Docker Hub or anywhere else, even if it's going to stay securely inside your environment, in general, we would heavily advise not setting up your container image with the secret in the code in a binary, because it's super easy. If I can get hold of that container, it's relatively easy to dump the file system. We'll do this in the lab. I'll show you how to do it if you don't already know. Even if it's a binary, you can use things like the strings command in Linux, if anyone's familiar with that, and find strings inside binaries and look for patterns. And if it's not a binary like that, we'll be using an ultra simple and very poorly written Python script today. So obviously I can read that as plain text, and you'll be able to see the secret straight inside there. And even if it's a huge chunk of stuff and a huge chunk of code, obviously, our ability to match patterns is super easy now. Here is, I think we've got an example down here that matches a JWT in a regex pretty well. It's maybe not perfect, but it would be good enough to generate a short list of JWTs to perhaps try against the back end. Same for other things like, username equals password equals user equals pass equals. All those things are really easy to find. So never hard code. It relies heavily on the security of how you're storing those container images. Even in, dev test, the thing is, we all know with dev test, I've done this. We all do things that like, well, let's get this working. Let's make sure the logic works. Let's make sure the code works. We'll worry about some of the security features about how we're going to store these usernames and passwords, how we're going to deal with environment variables. We'll get to that once we've made the core thing. After the next sprint, we'll do that after the next sprint. And then eventually the thing makes its way into live, and no one's ever quite had the time to go through and fix those problems. So just don't do it from day one is my top tip. Okay, so environment variables, there's loads and loads and loads of really good reasons to use environment variables and pass environment variables into your container. And I thoroughly endorse using environment variables for passing configuration data into containers. And we'll do some examples of that today. There's quite a few different ways of doing it, depending on the platform you're using, depending on your container environment. Like it's a fine and good thing to do. It's not such a great thing to do for secrets because they're relatively easy to read. So I can read, I can export my secret, I can inject it at runtime. We'll do this in the lab. We'll take you through that. The downside of that is that I now have a running container with an environment variable in it that's relatively easy to read. So I can examine a container, whether it's running or not, if I haven't deleted it. And then it's really easy to read the environment variables. Again, I'll take you through how we do that. So you can't think that an environment a container is safe if it's using environment variables for secrets. If someone gets access to the container platform, maybe not access to the container, maybe they're not in your group, maybe it's a contractor or someone else has access just to that sort of like whatever the container environment is, and they can run some commands on the command line, then they can see all the environment variables in your container. Now, it's nowhere near as bad as hard coding, because I have to have some access. But again, it's generally kind of not a great idea to run them in environment variables because they're just easy to read, just trivial to read. So the next thing to do is to use a secret. So in a secret environment, I am storing my secret. Now we'll do this. This is the most basic version when we have some secrets stored locally, just on our file system. But we have once it's in our container, it's running as a secret. So if I have a container running as a secret, which is basically turns up, certainly in Docker and in Kubernetes, and probably in most other versions as well, turns up as a sort of a runtime file system, run secrets or something like that. Then I end up with my container in the secret, and it's in a file system. And if I dump the file system of a container, the secret's not there because it's a runtime file system. It's blank and empty once I've killed my container and dumped the file system. So that's pretty good. It doesn't show up as a container variable, but of course, if I compromise the host and I've still got the secret stored in a text file on the host, then again I'm accessing that container. So that's not bad. It's not a terrible way of doing things, but the kind of the real solution is to use some kind of secrets manager. Okay, so if I use a secrets manager, I put my secret into the secret. Now, obviously, at some point, I have to have access to the secret. I have to add it to the secrets manager. That's kind of unavoidable, but I can do that in as secure a way as possible. And then my container image obviously gets turned into a running container, and the secret is stored in the file system. So that's good. And then obviously, if I dump the file system or examine the container, I don't see it in the file system. I don't see it in the environment variable. And if I compromise the host, I still can't see the secret. If it's a secret manager, it's essentially a one-way door. I can put it in, I can pull it out with the right privileges for a running container, but as someone that's just maybe got access to the host at some level, I can't get access to that secret. So that's kind of like that's pretty much the maybe not the gold standard, but the best way of doing things is you run some kind of secret manager, inject it into the container, store it on the container file system, and read it from your app, and frequently reread as well. So in our simple app today, the app fires up, we read the secret from the file system once, and we just use that for the rest of our activities. That's actually not the best way of doing it. The best way of doing it is to frequently reread that secret from the running container file system. Now, why should we do that, you ask? Well, that all comes down to secrets, rotating and revoking secrets. So I have my container running, it's got the secret from the secret manager. I have a service that's authorizing the connection. Ideally, that service is using an identity provider. So, I'm using some kind of identity provider. So I'm passing my secret, my authorization token essentially into the service that's authorizing it. That is validating that against an identity provider. There are added complications with things like OpenID Connect, which we won't go into today, but essentially that's still the workflow. There's some extra secrets flying around. Now, let's just assume that my secret has been compromised. Maybe not from this system, but from another one. Maybe I'm not sure. So what I want to do, maybe I've had a breach. Maybe IDP has reported a breach, whatever. So something bad has happened. Obviously, the first thing I want to do is to rotate that secret, and the identity provider is like invalidated previous secrets and has created a new secret. I now want to inject that new secret into my secrets manager, and my secrets manager wants to give that to the container. And so the container can then use the secret. Now, if I'm just reading once and never rereading, essentially I'm going to have to restart the app or restart the container to reread that secret. But if I have something in my system where I'm periodically, probably not every time I need to make a connection, because that could be quite resource intensive, but if I'm periodically rereading that secret into my app based on a counter or something else, then I'm going to be able to use that secret, because essentially then I'm going to, if I try and connect with my old secret, I'm not going to get let in, and if I connect with my new secret, I am. Okay, so before I head to the demo, I'm just going to see if there are any questions or chat requests or anything. Anyone need to know anything? It doesn't look like it. Feel free to ask. I think
we're in great shape.
Okay, so feel free to ask questions. We're running about right on time, which is really unusual for one of my webinars. Okay, so let's just click something over here that you can't see, and we will. Right, so I'm going to take you through now. I'm going to share my screen, and I'm going to take you through what the lab looks like. This is broadly what the lab will look like for you too. I don't think I have any extra options set up as a lab creator. So I'm going to click this and then click this. I don't know. Select the tab to preview. There we go. That one. Share that. Okay. Hopefully everyone can see my screen. I will make this screen a bit larger when we get down to the typing things, because I know it can be a little bit small on the lab. This is exactly what you'll see when you come in. It takes about a minute or so to start the lab, maybe a minute and a little bit, because essentially everyone gets their own virtual machine provisioned. It just takes a second or two to happen. We've kind of tried to make this as painless as possible by loading as many things as possible. If you go and do this lab offline, you'll be able to watch a run-through demo of this lab, which is here on YouTube. It's also, if this lab or my access explodes during this session, I can play the demo. So we have something stuck up our sleeves. I'll run you through, if you didn't do the lab last week and you're new to this environment, I'll give you a quick tour of the lab environment. I think it's really nice.
Hey, Robert, I'm going to interject. While we're waiting for this to load, we actually just got 3 questions in the Q&A.
Okay, great. Let me.
We can follow on the lab, and
I can
pick one you want to.
So I can leave this up and I can look at the questions.
Yes.
Are you going to show the paradox of how to needing a secret to fetch a secret? No, I'm not, because that is a paradox. I think mostly the way I have seen this solved, and it is a paradox. It is a problem. Mostly what we're going to rely on is the identity in some way of the requesting object. So you do have to, when we went back to that early slide where it says control access to the secret, that is, I'll admit, a really glib way of saying it. And so it is a perfectly reasonable question to ask. Most environments, you have to at some point be able to identify a machine and say, yes, you are valid to have that secret. Now, you can do that in a number of ways, but it is always a weak point. It's always hard. You probably need to use multiple factors if you can. So if I'm running in my Kubernetes cluster and I am that machine, and I've been started with these privileges and have the right container security policy, I should be allowed access to that secret. But it is always a problem. You're completely right, because there is always a chance of compromise. So, as you say, you can set it up so that you need the secret to get the secret. But then if I get the secret, that means I'm authorized to get the secret. If I obtain the secret, that means I'm able to get the secret, then it's all broken, which is why you have to have the ability to rotate and remediate secrets. And rotate, but it is tricky, and I'm not going to try and get into that today. That's definitely a 201 question. Mohammed's asked about what are we going to show? What tools we're going to manage secrets? Because he didn't manage to get here on time, which is completely reasonable. I'm rarely on time for any of these things when I'm not giving them myself. Yes, we're going to go through it in the lab, and I'll show you, and it's explained in the lab that you can do post this. And you can always come back and watch this session again if you want to get through it as well. But we will talk about some secrets secrets management at a really high level. Like, I'm going to use a very, very simplistic one. You can use the Docker Swarm secrets solution. It's nowhere near as full featured as other systems out there, but it works really well for showing a lab. Okay, hopefully that got to those two. So you'll see this, you click start, and you get this lab environment. And the way it works is, and I'll show you, you can slide this around, so I can make the make this bigger. The sections expand backwards and forwards. Most things are clickable for copying. So we have mostly tried to make this as simple as possible. See that we have already downloaded some content for you. I will, if I remember how, I will make this bigger. Make it a little bit smaller. How's that look on everyone's screen? Is that reasonable? Hopefully that should be reasonably to see. You can obviously slide this around and make it how you like. So I won't read all the instructions because we will be here forever.
Actually, Robert, can you like Control Plus or something? The left side is a little bit small for the type.
Yeah, sure. I can only make everything bigger. Unfortunately.
Yeah, I know it's not ideal, but you can.
How's that?
Yeah,
is that better?
Yeah, I think so.
Okay, that's great. I can see that. I don't even need to put my glasses on. Fantastic. Okay, so we'll go through this. It's super simple. All of the instructions are in the side here. Mostly the black, where it's a command you're going to use, you can just copy it like that, and then you can paste, do whatever works for you in the environment. I can do Control-C, Control-V on a Mac keyboard. I noticed on the Windows keyboard it doesn't always work as well. This is the little repository we've cloned for you. It's got lots of the usual GitHub stuff, and there's an API server and an API client in there. So if we head into, if we look in the API client, I'm going to first make the secret not a secret at all. So this is the secret. You can see here it's just a big long string of text, but that is actually that's actually just a signed JWT. Might even not be a signed JWT, but you can sign and encrypt. But it doesn't matter. They all look roughly like this. And this is an authorization token that I will use against an authorization server, which is again a very, very simple system we have set up. I'm just going to make the run the authorization server. We just need to actually Docker build it and then run it. So again, I'm just going to build my API server, which is the thing that's going to listen to the questions. There we go. And then I'm just going to run it. If anyone's familiar with this, we're just doing running and detaching it. So listening on port 80. So I'm not worrying about encrypting my secret, my communications between the two. Obviously in a real environment you would, but we're doing a lab, and that's not the purpose of the lab. The purpose of the lab is to kind of
hey,
like
Robert,
show us.
Sorry to interrupt. We've got a request to zoom in a little bit more.
Sure, no problems. Okay. The balance between how much I can show on the screen, but that's probably as good as I can manage. You can, if you're on 24 environment, you can slide things around in your window as well to make things bigger. So if you're watching, if you're using the platform, you should be able to move the media player and make it slightly bigger as well. Because I found that before I realized that you can slide it around. So hopefully that will help you a bit as well. Okay. So we've started the API server, and we can test the authentication server out really simply. I'll just do a simple curl command. It's just going to do a get to it. It's nothing complicated. And if it's all working, it's going to tell me 401 authorization required. So obviously that's not working because I'm not allowed in. And that's exactly what I'd expect because it's up to authorize it. Now this time I'm going to pass my my token that we just looked at a minute ago. I'm going to pass that as an HTTP header with the authorization and bearer, which is how we do a JWT. And I'm just going to pass that in and check that it works. So if I do this, so this is just sending the token as a header, and there we go. This time we get something completely different. Actually, I've used a curl-i, so you get a little bit more information, but I get 200 OK. I get this header back, which tells me this is actually encoded in the JWT as the name of the API key, and I get a successful authorized and a value back from my API server. And it's just a mock-up. It's nothing clever. It's literally a very, very simple NGINX config that passes this back if the API works. Okay. So there you go. We've completed the setup, and we are going to do the tab to continue. So I'm just going to do a check. It will do some basic checking for this environment, and we will go from there. So if I press check, it will tell me that it's worked. If I've done something wrong, then it will tell me that I've done something wrong, and I can have another go. And it won't let me move to the next challenge until I've completed this challenge. So there's no easy way of doing this. Okay. So again, there's lots of setup. You can read all this at your in your own time. So what we've done here, I'll just show you this to make. So I've tried to make this super easy to understand. And what I've got, if we look in here, you will see there is an app.py. And what we've got also here is an app versions directory. And so nearly every time we're going to do, we're just going to copy a version of that app from the app versions directory to be app.py. So in this case, I'm copying, and I've cunningly named them, very bad hardcode.py into app.py. So that's going to copy this in here, and then I can now take a look at the app. Like that, I suppose. So this is the full, this is the full extent of the application. All it does is it, here I've got my app. Down here I've got, I'm using the URL lib Python app or Python library. Super simple. Makes a request to the Docker internal. I will talk about that host in a moment, because that just is another name for the local host. And it's just opening the request, printing the response, or printing the error. It's super, super easy. And then you can see there, we talk about this. So we can build and run the client. We're just using Docker Compose for this. It's easier to use Docker Compose for this particular, for this thing. And I'll show you the Docker Compose file actually while we're here. You see we're using the Docker code hardcode.yaml. Let's just see what goes on here. It's super simple. There's nothing really complicated in here. As you can see, it's very short. It's just saying build the API client. This is the image to use. This is the build directory, and this is just saying configuring host docker.internal to be the local host, because obviously our API server is listing on the local host. It's a slight cheat, but it works perfectly for this. So we run this to test. And it's going to come back, and it's going to run the thing, and it's going to download and build the application. And we're going to get the API client 1 200 success API key. So that's worked. I mean, amazingly, we've hard coded the JWT in there, so that's not really a surprise. So let's talk about how we retrieve that secret from the container. So I'm just going to make a directory. Should really actually copy and paste this, because my typing is terrible, and I usually make some sort of typo. Okay, so I'm going to have a quick look at what containers I've got running using this Docker PS. I've got a little format string in there just because it makes it easier to see. And here we can see, here is my API client that I've just run. So I can identify the container ID. Loads of times we'll be identifying the container ID in this this environment. So what we can do is we can actually export it with this Docker export command. So I'm going to then Docker export it using the container ID. Now, I don't need to have access to any of the source code. I just need access to the container and to be able to run it once. The container's not actually running, so it doesn't need to be running. I can just have access to the image. See, when I ran it, I didn't have a delete afterwards. But if I can get hold of this container, then I can run it. This takes a second to run because it's dumping the file system, but it doesn't take too long to run. So I've now got a tar file of the API. I could just kind of like grep through that looking for files. One of the things I can actually make use of is this Docker history command. So my Docker history command is going to tell me how this Docker image was built. So this will produce a load of text. But if I look up here, I can see over here these like first 3 lines where it looks like maybe it's like user app src and app.py. So I think I can probably make even if I hadn't seen the rest of this and I just had the image, I could be a reasonably good idea that perhaps that in user app source app.py there might be a place to look at. It might be a good place to look, or I could just grab the whole thing. But let's just extract that one file. So I'm just doing an extract of the individual file from that tar file, and then I can obviously just show you the file. Now, obviously, you've seen this, but that's because we had the source app. But now we've just used the container image that's run, and I can see my JWT, and I can obviously run off with that and use it. Okay, so I'm just going to click check to continue. Hopefully, it's going to take me to the next lab. There we go. How are we doing for time? Oh, not bad at all. Okay, let's get going with this one. Okay, so now we're going to do the same thing, but with an environment variable. Okay, so I say we won't go through this whole thing here. Let's pass an environment variable. So we just need to do the same thing. We're just going to copy the app up there. So then let's take a look at that app. So I can just there we go. Okay, over here, a little bit of an extra bit where we're basically looking for this JWT in the environment variable, and then we'll use that to build our authorization token. So rather than hard code it, this line is just reading it from the environment variable. There's no point me talking at length about how Python works because you may not be using Python at all. So, and now let's take a look at that, the environment file here. So this just has this environment line, JWT, which means it pulls the environment variable locally and puts it into the container. There are a bunch of ways of doing that. I do talk about them in the instructions to this lab, but for the interest of time, we'll just crack on. So I'm going to run this, and I'm going to build the client and do the same thing again. And I've got an unauthorized, and the reason I've got an unauthorized is because I don't have that environment variable set. So let's just set that, and then run the whole thing again. We don't need to build the image this time, but there you go. There we go, software. So I've set the environment variable, and I've run my thing. So that's cool. Now we know that the base image doesn't have the JWT inside it, so it's a bit safer. But I can still look inside my container, even though it's not running anymore. This container runs once; it doesn't run continuously. We will look at what container that runs continuously a bit later on to make life easier. But let's take a look at that. So let's grab my container ID, and then let's just do a. So I'm going to do this Docker inspect command. Docker inspect, and I'm going to substitute in the container ID that I'm running. Just grab that. This. And I get a load of stuff, and much of which we don't really care about, well, not for this environment anyway. But you will notice up here there is an env section, And in my non-running container, it's not running anymore. I've still got the image lying around. I've got the image of the ghost of it running because I didn't delete it. I have my JWT and obviously all the other things that I might have as well. So, you know, environment variables aren't bad. They're not a terrible thing to do. But you have to know that they are readable from outside of the container. I don't have to get access to the CLI of the container. I don't have to get inside it. It doesn't even have to be running if I've left the image lying around. Well, I've left the image of that running container lying around. It's relatively easy to read container images. Okay, I have to remember to delete that. Hooray, it's telling me I've done it right, which is good news. Okay, we're going to use some local secrets. This starts making life just a little bit more complicated. Not too bad. So this is possibly a good thing to do in a dev test environment, depending on what you're using in the long term. So in most environments, it'll at least be able to build your app that runs properly and reads secrets from the file system. In Docker and the system we're using, you end up with a run secrets file system. And we pass a locally stored secret to the container. So let's show you how to do that. Let's go and do the same thing. Amazingly, we're going to then copy the better secrets file. So let's take a quick look at this. Okay, so this is again slightly different. So there's a whole huge difference of opinion. I like to call things different things. I get confused if the same variable name is used for different stuff. Other people prefer it to be. So our jot file is where we're storing the secret in run secrets jot. But this is where the JWT is stored. So maybe I should have used that. And then I'm just reading this from the line. I'm reading the first line. I'm assuming it's only got one line. So it's a very, very shonky piece of code that could break fairly easily, but maybe next year we'll do something better. And then it's just going to build that bearer from reading the file system. So it's really, really simple. So let's just take a look at the Docker compose file that goes with this. And again, this will look just the same pretty much, except for over here, I'm naming my secret jot, and I'm reading it from this token1 file. And then in my container, I'm saying this is the secret. So I reference this secret down here. This secret references the local file. So I mean, not perfect, but not terrible. So let's see if we can run it, and it should work. I mean, the first thing it's got to do is actually work and give us a 200 success back. Great. Okay, so that works. Now the question is, can I get this information? So let's just see if we can see it anywhere. So let's see, just grab the container ID, we'll need that. So the first thing I'm going to do is I'm going to inspect it with a Docker inspect. He says confidently, try and paste, failing. Let's grab this, see this. Control V that there. Whiz up here very quickly to the environment sections, and no, we don't have that, so that's good. That's kind of what we'd expect for this, but it's always good to check. Let's just do the same thing and do an extract, and we'll do the same thing over here. Docker extract. Should have probably typed that so I can reuse my container ID, but we'll just steal it from over here. Find the container ID. So much stuff. There we go, this one. Use that down here and put that in there. So let's just do a quick extract. It takes a second. Let's see if we can find that file. Okay, so there is our run secrets jot. So maybe that's a problem. Maybe because we can see it's there. So let's see if we can find it. See if we can extract it and see what we get. So I can extract the file, and then I'm going to cat it, and it's not there. So just rerun that to prove my point. Okay, so what we've done now is we've got no, from the container image, I can't see it in the environment file. I can't extract it from the the running system. I don't have a shell. Do I have a shell? My container shouldn't have a shell. So that's relatively secure. Like the container's running. If I don't have a shell into it, I can't get to that file. If I dump the file system, it's not there. If I examine the environment variables, it's not there. But obviously, if I see the upper thing and then look here, obviously I've still run this with my token still there. If I rename that token, you can try this in the lab. Renamed, don't delete it because you'll need it again, but rename token1.jwt to token1. Whatever, and try and restart your container. It won't work. So you have to have it at container startup time. So that's kind of like, we're about 50% of the way there. We're not doing perfectly, but we've at least built a more secure container environment. So let's do the next and final section. And then we should be done, and you can ask some questions and start the lab. Okay. Okay, so let's use the secrets manager. This makes life slightly more complicated. There's a load of stuff that you can read talking about secrets managers, most of which I've already said. So unfortunately, we have to use Docker Swarm for this. I mean, I guess Docker Swarm isn't a hugely used system anymore, but it's nice and simple, so it's good for labs. But the secrets manager we're using here, although it's simple, is really analogous to any other kind of like secrets manager you might use. So it's not, it proves the point really nicely. So this will start a Docker Swarm environment, and I'm just going to create a secret using the Docker secret create, secret name, and the file name. So really easy to create a secret. I could obviously now delete that secret, or I could have passed that secret in just from a cut and paste, or we don't really want secrets lying around in our file system, but create the secret. You'll see that it creates that. I can examine the secret. I can inspect it. It's going to tell me lots of useful stuff about it, when it was created, when it was updated, what it's called. I can give it labels. I can do all that sort of stuff as well. Obviously, I can't see the secret itself, so that's kind of the key point. So the way it works is going to be exactly the same as the last file, because we don't do anything different. We're still reading it from the file system. Let's take a look at the secret manager. So the only difference here is we're saying external equals true. That's the only difference to our file. Our while true is slightly different, so I'll show you this as well, because I want to read from when I run this with Docker Swarm command, I don't get the output straight to the CLI. I have to tail a log to see it. So let's just take a quick look at that. The only thing that's any different is I'm still reading the file up here. It's exactly the same piece of code to read the file. The only difference is that it's doing a while true, sleep for 5 seconds, make the request, and loop round and round and round, just because then we can see that in the log files. So it's nothing complicated. I do need to build the container this time as well, because that's not part of my Docker Swarm, my Docker stack deploy command. But it doesn't take too long. It takes a slightly longer because it's building it successfully. Okay, and then I'm going to use this Docker stack command, Docker stack deploy command. If you look at it, it basically is using the same compose file, and then giving it a name. So it just sits there, and we'll just run this. It will do this, and then now obviously I don't get the output, so I'm going to actually have to find the container ID again. And there's my container ID. If I called it secret stack up here, what's the name of the stack I created? So that's my container ID, and I need to just tail the logs to see the container. So again, it's not super exciting, but we'll tail the log. This, he says, we can't copy and paste properly. There you can see it's just looping around every 5 seconds, and see it there. So we're working, and now we could go through. I'm not going to show you that now because we'll run out of time. We could do examining the container. We could do all those things. We could extract it. We can run that stuff. Should be sure that we can't see it. Let's just talk about how we rotate the secret. Now, unfortunately, one of the things that Docker's secrets isn't very good is it doesn't let you update an existing secret. You have to delete it and start again. And so, fortunately, we need to kill the service. This is where a more advanced secret manager or a more advanced container management platform would be better. But this is really super easy to run in a lab in a small environment, or to run at home with no extra software. So I'm just going to remove that service. I'm going to delete the secret. I'm going to let's assume that I'm in the extract directory. So I'm just going to do that individually. If you follow the instructions, you will always be in the right directory, but I'm not here. So I'm just going to use a different token this time. So we're going to create it from token 2. And then I'm going to deploy the service again. And then we'll do exactly the same thing. We'll do a Docker PS. Just like that. And then we'll do a there we go. We've rotated the secret. We're using a different API key. If we looked up here, we would be using API key 1, using API key 2. So that's a really manual and not super attractive way of doing that. But it kind of illustrates the point that you want to be able to make it relatively easy, ideally without restarting your container. But that's kind of one of the problems we have with using Docker Swarm secrets. But the other thing to note is that I'm only reading that secret once in my app. So again, I wouldn't have picked this up. I'd still have to restart my container if I didn't have some mechanism of rereading the secret. Okay, so that's pretty much the end of the lab. I can check it here. Now, in this lab, the API server doesn't differentiate between the thing. There is a next section that when you run this, I do want you to go all the way through to the end. It's important to both get your badge and also to tell us what's happening. So this gives you some instructions of how to do things. You can obviously drag this across here. And then if you can go all the way through to the end, and this is kind of important. If you think this lab is even remotely useful, you can give it any rating you like. Give it a genuine rating. If you thought it was terrible, then tell us. That's fine. I'm most interested that you give it a rating and that you click finish, because then that shows up that the lab has been finished. Okay, so where we are, well, we're not too bad. Slightly behind time, but not too bad.
No, we're doing great.
Okay.
We don't have any more questions in the Q&A right now, so why don't we give people just a moment to pop some questions in. There we go. Yep. We'll get that over the Q&A slide. Look at that. You even remembered to unshare your screen.
I'm evolving as a human. I like to think that,
hey, we're capable of change.
Yeah, it's only taken me like 10 years or something to slightly get on top of things.
Yeah, well, I still can't find the mute button, so.
Yeah. Okay.
Yeah, let's just give it another moment for people to pop in their thoughts.
And we're still here all the time, so it's not a problem.
Truth. While we're waiting to see if there's any Q&A, as I put in the attendee chat, we will be here for another hour or so. And so if you've budgeted the time to hang out with us, wonderful. It's a perfect time for you to complete the lab that Robert just did. If not, that's totally okay. You can do it on your own time, all the way through the end of the month of March. All right, we have a question from Natalia. I'm going to go ahead and toss it up on the screen so that everyone can see it. See if I can. Oh, you clicked the thing, didn't you?
Who, me? Oh,
yeah, you. See. Unclick it.
How do I do that? Hang on.
I think you're good.
I'm going to push it to the slide area. I can do that. I'm going to push it to the slide area all by myself.
Look at that. Oh, it just says, when can we start the lab?
Yeah. When can we start the lab? Well, that seems like a reasonable.
You can start the lab if you like, but it looks like we have a question which you may be interested in hearing. So again, we'll toss this up so that everyone can see it.
Can you talk
about sub-request authentication in microservices?
Can we talk about sub-request authentication in microservices? So do you mean that, and I'm going to ask you to clarify this possibly. For instance, I've authorized, one service is allowed to talk to another service. It's authorized between the two, maybe using something like MTLS. But then if it wants to make a specific call or a specific request, it needs to authorize again, or it needs a different set of author. It needs to be kind of in some way additionally authorized to make certain calls. So like one client can make a set of gets to get information from an image catalog, or everyone always picks an image catalog, and one client has authorization rights to upload images to the catalog, in that sort of service mesh that we might have. So in that case, that adds another layer of complexity, and so I think at that point you're kind of getting into how the back end is configured as well, and what sort of authorization component you're using on the back end. It's something like NGINX. If you're using NGINX as a sort of a service proxy in your microservices, then absolutely we can have differential authentication required for different application paths. So you can absolutely have, a service listening that has a bunch of API endpoints. It has a get, a post, and obviously directories and service points underneath that. So, and you can completely have differential auth for different request types and different paths. So that's the way to do it. It does add a layer of complexity, but it's completely possible to do in that environment as well. So you can have different credentials required using, for most of the time, I think I would advise using something to proxy those connections in. If you're going to do that, don't try and code that into your app or even into your container. Have an auth proxy that's easy to configure. Jen's answering this question like offline, but someone's asked if they can do the lab anytime before the next session. You can do the lab anytime before the end of the month when the lab goes away.
All right, we will be here for any more Q&A, but it looks like they're coming in a bit slowly. So I see that there's a question about what's the URL. That URL is in I just dropped it. If you look in the Q&A, it's there, and it's also in the resources tab on your screen. So if you click the link in related content, which our host will go ahead and highlight for you. Now, one thing that I'll note is you can also run the lab locally using the tutorial that's linked in that related content box. And so here's what we recommend. Do the lab exactly as written the first time through using our browser-based lab, because if you try to do something creative, you're probably going to break it. So let's stay away from the creativity in there. But then once you're done and you've seen how to do it the way that we've set it up, then you can take our guide that's in the related content box, and it's also available from the agenda page, and you can go crazy, do whatever you want with it. But we've given you the instructions in blog format so that you don't have to stay in that environment. But we've got it set up in a very specific way where it might not appreciate creativity as much as we do. So that said, if you have not already launched the lab, to do so, you're going to click the link in the related content box. If for some reason that's not popped up, just look for the little paperclip icon. You're going to create an account or log in using the exact same email address that you used to get into this platform. And then it's going to take you probably 20 to 30 minutes to complete the lab. We recommend, again, probably a little more than that in case you want to do it twice. Let's see here. Okay, nothing else in the Q&A that we need to get to. And then we'll give you up to 3 attempts. And so it is timed, and we do have a minimum or maximum number of attempts, and that's just because we have to pay for the platform. So if you want to do more attempts, just use that lab guide offline. And then the best way to ask us questions is through the attendee chat, though we'll keep an eye on the Q&A also. So Robert and I will go off mic, go off camera, and just hang out here for the next hour, and we'll just come on as we see questions. And so we suggest you leave the webinar up and running so that you can ask questions or you can hear us answering other people's questions. Oh, you know what? We do have a question that I'll go ahead and pop up on the screen. So I use some online services to run my container like Hop.io, and they use env variables for secrets. So using secrets like that will be not good for security.
So,
or I think the question is that?
Yeah, I mean, it's not terrible. Like that, it's much better than hard coding. Okay, so, and in an environment where you can be sure that or you can be, not sure, but you can be reasonably confident that no one can access your running container. So obviously you always have to trust your service provider because they can access all the things, But if you're reasonably happy that in your environment, the chances of me being a bad person can't run that inspect command, maybe that it's secure enough in an environment that an attacker's never going to be inspect a running container, then I would be reasonably happy using, secrets as environment variables. If you're running in like a self-managed environment where you're not completely confident that nobody who shouldn't have access to that container environment doesn't have access, I generally avoid them. But if you're running in a service provider environment where maybe your whole instance is very, the whole environment's very carefully locked down. There's no third-party access to be able to run any commands. You have a way of encrypting those environment variables so that, again, they're not accessible where they're stored. Then I think it's fine. It's not as good as running it with a secrets manager for sure, but it is.
Robert, one of our colleagues is suggesting things. We talk a little bit about how this might be different in Kubernetes versus in a non-Kubernetes environment. Does that make a difference?
Yeah, so if you're running in Kubernetes, then there's already a really good secret system in Kubernetes. I still wouldn't use. I still would avoid environment variables for secrets when you've got a secrets solution in Kubernetes already. Obviously, you don't necessarily get those Docker inspect commands available, but nothing is perfect. I could potentially be able to run a binary or something like that in that environment. So if you're running Kubernetes, then use the secrets built into Kubernetes or the service provider. It's really going to depend on how confident you feel in that environment about whether someone's going to be able to inspect your running container. However you might choose to do that is kind of like, it's up to you. There are definitely times, like inside of a well-managed Kubernetes environment, inside of a service provider, like, if it's like a Fargate type thing where it spins up, runs, dies, where you have no access to and you're trusting that there's no access to the underlying platform. That's not automatically a bad thing. It's whatever you do, it's much better than doing hard-coded secrets.
Right on. I did forget to cover one logistical item. I think, Robert, you did a great job of demoing how the Instruct platform works, so hopefully it's pretty intuitive for people. But you do have in the upper right a progress bar and a time remaining little counter, so you can keep an eye on that. You can see how far you've gone through. You can resize the window. Checking is going to run against a script. Finishing helps you qualify for the badge. So with that said, I don't see any more Q&A. So this is where we'll cut off the recording that'll be available on demand later. It takes a little bit of time for the video to process. So it'll probably be a couple hours before it's available on demand for those of you who just joined us. Otherwise, we'll be hanging out, right, Robert?
Yep, we'll be here. Hit us up on chat or the Q&A. Chat's probably good for dealing with lab stuff. If there's a particular problem that someone's having with a lab, and I think it might have been a source of general confusion, then I'll bring it up on screen and try and replicate the problem or demonstrate the issue. But feel free to just have a play.
Right on. We'll be here. Thanks. Hey, Robert. We just got a couple of questions in the Q&A. I'm going to go ahead and toss one up on the slide area in case anyone else has the same question.
Yeah, okay. I am just looking at that now. Unfortunately, for some reason I can't see the screen very well. Hang on, let's see if I can turn that off.
All right, I'll go ahead and read it out loud for anyone who is still listening. The exercise specifies the secret feature in Docker Compose is why we are using that flavor of Docker. Can't I do the same with standard issue Docker/podman using volumes and mounts with regard to local secrets?
Yeah, I mean, that's essentially exactly the same thing. The difference is the reason we did it like that in the lab is so that we can build into the next part of the lab, which is to use the secrets manager. You still the advantage of using secrets as opposed to a straight mount is that if I wanted to, I could delete the underlying secret from a running container and it will still work because it's been passed in as a secret from the local file system. So admittedly, I can't restart that container without that secret being present. But so if I mount a volume, then that volume is accessible potentially elsewhere as well. Whereas if I run it as a secret that it's passed into the container, I can then delete that secret locally. The primary reason, and to be honest, in a real world environment, we probably wouldn't ever use that. In a real world production environment, we wouldn't run that local secrets solution. It's probably quite good for test dev because you can use the same code in your app and a relatively small change to any compose file to then translate that into an environment in production where you might be using a secrets manager. And also because it built a nice progression through the lab as well. But functionally, that's very, very similar using a local secret to using a volume, other than, let's say, once the secret's read into the container, you can delete the local container, the local file, and it's not then readable. But obviously, if you then try and restart the container, it won't start with the app with the secret. That kind of covers the other
rephrasing. I just want to make sure. I think you answered the rephrased question as well. So let me just pop that over there. Oh, come on, little machine, you can do it. There we go. I think you.
Yeah, I think that's the same answer. So from an operational security perspective, you're broadly right that running a local secret with a secret on the local file system and using that sort of Docker Compose secrets with a local file isn't stunningly different from running a volume mount. The only thing I will say is that once that secret's been passed into the running container, you can delete the local file, but obviously then you can't, as I say, you can't restart the container. So it's not something I would recommend doing. But what it is probably if you write your app code locally to read from run secrets, and then that works generally that's going to work nicely, or if you're using Kubernetes or whatever, it's going to work nicely in your on your local machine where you can use a local secret, and it's going to run nicely in a production environment where you're using a secrets manager. So it's not local secrets are not a production solution, but they are an easy way to match dev with live. And they're a good example about how we progress through our secrets in the lab.
Okay, we have a follow-up. Let's say my app follows the worst possible practice. Hard coding secrets are similar. What is the least effort, high impact method to improve security that can be done done by DevOps without involving developers? I.e., how can we fix this ASAP? And then maybe go do a better job later, right?
Yeah, I'll invite the rest of the audience to weigh in on this question, because my immediate thing is like, buy a lucky talisman and hope that your container never leaks outside of your environment. Now, I mean, all of this relies on, we have to accept that things go wrong, stuff leaks out, people compromise it. If you're hard coding your containers, your secrets into your containers, those containers are essentially secrets. So you need to be, they're a secret with a rest of a container wrapped around it. So if you are, so therefore that container image, you have to treat that as if it's a secret, and therefore you should be obviously making super sure that it's only staying locally, that you know who's accessing it, that's who's using it, and that there's no chance that someone's going to accidentally put it on Docker Hub, that your access to your local container registry is fairly well locked down, and that container then becomes a secret. And so you kind of put some stuff around that. So there are definitely operational practices you can put around to be sure that that container is stored in a registry securely, and that you have authorized and logged access to who's pulling those containers from your registry, and that it's definitely not stored somewhere with any kind of public access. So there are DevOps things you can do to make sure that you're, if you're hard coding secrets, that because obviously you build the container, you run the container, you then need to, you should always be super careful about how you're storing your containers and who has access to the runtime, container environment anyway. But then you need to be extra vigilant. But that's my only immediate thought, is that makes your container a secret, and therefore clearly you can't put your containers anywhere where anyone else can get to them, that you don't want to get to them, and that you have to then, presumably you're going to use a private container registry. So therefore, how do you control which apps are authorized to pull from that container registry? In fact, if you come and do next week's lab, which is not about secrets management, but it is about doing blue-green deployments of containers. In there, we're using Azure as our container registry, our container environment, using the Azure Container App stuff. And you'll see as we go through that some of the sort of slightly tedious, if I'm honest, parts of that lab, but very, very important, is to create a managed identity that has the rights to pull containers from the container registry that we create as part of the whole thing. So that's the kind of thing you need to think about, is like, how am I controlling access to that container registry? Because in there, those containers have secrets that can potentially be compromised. That's a really long-winded answer, but I invite anyone else on the call to throw their thoughts into the attendee chat, because I'm sure I'm not the authority on that answer.
Right on. We will go ahead and go off mic again for a while. We've got about another 20 minutes here in our office hours time. So if you finish the lab, let us know what you thought of it. Let us know what you learned, etc. And I'm hearing from a pal of ours who's on the back end, who has quite a bit of dev experience, that basically you can't just solve it on the DevOps side, as Robert was summing up nicely for us.
Yeah,
so
I think you can do your best to make a secure environment, and you can't solve it. I mean, to be honest, there are no perfect solutions to secrets management. There are better and worse, and you can do your best, but that assume that at some point your secret's going to leak mindset, and make it so that, if you're using something like a JWT, it has a reasonably short lifespan. When you create them, for instance, you put a not valid after is one of the fields you can create. Make sure that if you do need to rotate those secrets out. If you find out that something's been compromised, that you have, at best, you have an easy, fast mechanism to rotate that secret and invalidate the old one. At worst, that you have at least a practiced plan for it. Now, I completely understand if you're using a backend database that has a local password solution, and you lose the secret for that, then someone's going to have to go potentially change that at the back end, and it's not going to be necessarily super simple, depending on what the back end is. But if nothing else, have a plan for when all things go horribly wrong, and assume that the things are going to go horribly wrong, and the plan is going to have to be put into effect at 3 a.m. on a Sunday, because that my on-call life back in the day, we didn't have, it was no one had coined the term DevOps last time I was on call for sysadmin type stuff, but you can always assume that the worst disaster is going to be happening at the most inconvenient time, and that there may not be, your third line support might be on their own, or your DevOps support might be on their own. They may not have anyone to call. So a planful thought about each of your secrets identified in your environment, what the impact of that secret being compromised is, and what the remediation plan stored somewhere that someone can access it is a good idea. And we are at time. So Robert, thank you so much for your time today. We'll say your expertise with doing things wrong, because we can learn a lot from doing the wrong thing, right? Some people's lives only serve to be a warning to others. Fair. So hopefully you've enjoyed this session. Please do take the very short survey at the end to let us know what you thought. Do the lab. You can access these resources anytime. It'll take us a little bit to get the on-demand recording of this session up. It has to process first, but we'll send out a message over in NGINX community Slack when it's available. And with that said, have a wonderful day.